The Pythagorean relationship of a squared plus b squared equals c squared is not relating the three sides together, because those three sides really are not related. We can't say a plus b ever equals c. That's never true. However, the Pythagorean relationship shows that in a right triangle, a squared, so this area here, plus b squared, which is this area here, these two areas add up to the third area off the hypotenuse, which is c squared. And again, the relationship then is about the square areas and not with the three side lengths, because these three sides cannot be added together. So when we solve these, really we need to make sure that we remember that we're dealing with squares. We're dealing with this 100 square here. We're dealing with this 16 square here. And that's going to add up to this square, which is 116 squares. And to solve for x, we find the square root of 116. So we go from area to side length with square root. Now, we're really going to keep it as square root 116, but as a decimal value, sometimes we do want to know the decimal values, and it's approximately 10.77. Okay, so that's about 10.77. So with this one here, same thing. Just make sure that we understand that this area is our biggest area. There's 36 squares here, 9 squares here, and we don't add to get this area here. Okay, this is the biggest area, and we need to then subtract. So this ends up being 27 squares here, which then makes, if I want to find the side length, x, we're going to square root 27. And again, square root 27, we should leave it like that, but if we want to know the decimal value, the measurement value, we can square root that and we get approximately 5.20. Okay, so again, the relationship is about the squares off the sides. It always adds to the biggest square. Okay, so if we want to find one of the smaller squares, we have to subtract. Here we have same thing. We don't always have to draw the squares, but we know we're solving for the shorter side. So we can set this up as x squared plus 14 squared equals 17 squared. Okay, then solving for x squared, we take 17 squared minus 14 squared. Okay, so let's just double check those. Okay, so we end up with x squared equaling 93 squares. And then that makes x equal to the square root of 93. Okay, so the square area is 93, so this length ends up being square root 93, which is approximately 9.64. Okay, but we really want to start using these exact values because that allows us to do a little bit more math with it. Now, sometimes it's a little bit harder to deal with exact values, but here we can see the mathematics a little bit better than just working out the numerical values. So this one here we have Sarah and Carrie. They leave from the same place. So they're going this direction. Sarah's going this direction. Carrie's going down. And Carrie drives 5 kilometers south. And Sarah drives X kilometers east. Okay. And at this point, this distance along here is going to be Sarah's distance plus an extra kilometer. And so we want to find the distance that Sarah traveled. Okay, we want to find that x value. So we can set this up as a Pythagorean relationship because it's a right triangle. Okay, and we have one variable here. So if we can find the relationship, in this case the relationship is Pythagoras, we can try to solve this. So we can say that 5 squared plus x squared equals the square off the hypotenuse, which is x plus 1 squared. Now, when we solve this, we have to make sure that we expand this out correctly, because this is a problem if we use exponents and plus together. It doesn't work. So here we end up with 25 plus x squared equals, now this expanded becomes x squared plus 2x plus 1. Now if you don't do that, this equation then becomes wrong. But when we do it correctly, we can see that the x squareds cancel out, and we end up with a linear equation. So we end up with 25 is equal to 2x plus 1. Solve for x. So we subtract 1 from both sides. We divide both sides by 2, and we end up with x equals 12. So Sarah's distance is 12. This distance is 13 along the hypotenuse. And that actually is a Pythagorean triple.